Hello, and welcome for this session about reducing an application footprint using Flutter on mobile. To prepare this talk, we have learned new techniques and tips. Some of them we are now using in production, so we are really happy to be there to share that with you. So thank you all for being there, and many thanks to the Flutter Connection team. Thank you. My name is François. I'm with Jocelyn and Adrien.
Hello.
We work on the SNCF Connect application. That's an application used by millions of people in France to find and use not only train, but sustainable solutions for travel and day-to-day mobilities. But this talk is not about our application. It's about you and us, what we can do to optimize and make our applications more efficient. So there will be a quick introduction, then we'll quickly focus on developer techniques. We'll talk about deferred components, tree shaking, even implementing our own custom eco-friendly mode. And we'll review some tools and techniques to test and monitor that. And that's it. But let's start with the why. So you might know the digital industry, the digital economy, it actually relies on real resources, infrastructure, and rare materials. For instance, the rare minerals to build batteries and mobile phones. So according to l'ADEME, the French Agency for Ecological Transition, in France, the digital technologies, they cause 2.5% of the world carbon footprint of all industries, and 4% of the global greenhouse gas emissions. If we look at the latest report, which was published in March, we see that almost 40% of the footprint comes from the user device. It's not the network, it's not the data centers and the cloud. And focusing on the device, on the user device, most of the pollution comes from the production of the device. And the mobile phones and smartphones being the worst because their lifetime is only 2.5 years in average. And lastly, and sadly, if we do nothing, it will dramatically increase in the following years. And for the rest of the talk, I will say carbon footprint or footprint, but it's not only about carbon, it's also the energy consumed and the rare minerals used, for instance. So you have to have everything of this in mind. And that being said, what can we do to improve our applications and reduce the footprint? So we'll focus quickly on the developer techniques, but before that, just a word about the product and the design. It might be obvious, but it's our responsibility and it's our choice to work on good products, useful products, to provide useful features. And we should try to implement a simple and an efficient design and make our services more inclusive, more accessible. We've talked about accessibility today already. The good news is, every time you try to improve your product, improve your design, generally it also improves the technical implementation, it improves the carbon footprint, it improves the accessibility because it becomes simpler, and it improves the user experience. So in some cases, you might even improve the business because you have more users and happier users. But we are at Flutter Connection. We are all developers, so from now on, let's focus on the developer techniques. And Jocelyn, we've seen that most of the pollution and the footprint comes from the user device. So what can we do if we want better applications, faster, smaller, more efficient? There are already techniques and tips we know, we heard about.
Exactly. So here are some basics. First thing we want to look at is CPU usage to check the battery consumption, and then the FPS, so that when you run on low-end device or old device, everything is smooth for your users. So every Flutter techniques is really well documented, and we won't get back to those. We can add to really check your consuming hardware like GPS, Bluetooth, camera, sensors, and really check that you release it when you don't need it. You also have to check your network usage, for example, implementing cache on your mobile. If you're using DIO, for example, it doesn't come by default, so you have to do it yourself and check that you're using some cache. Make sure to adapt the size of your assets, payload and storage to your needs. What I want to talk about next is dark mode. So basics here, LCD, which is kind of old device, old screen techniques, and completely independent from the color displayed. So dark mode isn't helping here. AMOLED can shut down some part of its screen if the color display is black. So full black theme is a really good thing, but also it tends to consume much less energy with darker color. For example, with our app, we have a dark blue theme, and we run some tests with our partner Green Spectre to show that we had a 25% reduction on the same flow, shopping flow, our shopping flow. So estimating that there will be around 30 million times this flow displayed on mobile phones, it comes to a saving of 7 tons of CO2 each year. So be it black mode, dark mode, don't hesitate to use it.
And so you also take a look at the threads in your application. You should use a good thread strategy because when you leverage the power of the Flutter framework, subsystem can optimize the treatments on the hardware, and you can use an optimized CPU core to save battery life and to optimize the UX because you won't overload the main display thread. So some tips about threads we can give you. You can use compute or isolate.run in the latest version of Flutter to deserialize big payloads. You can use isolate for multiple requests in parallel. Take a look also at schedule microtask if you want to prioritize some feature to run for your screen, and also use Work Manager if you need to make some stuff in the background. For example, if you need to acknowledge a notification for your server.
Repaint boundary. So Craig here just completely spoiled my slide. He explained it very well, so I won't get back to it. We are using it in our app with great results. So as you can see on the left, with our home screen without repaint boundaries, and on the right with repaint boundaries, with your beloved Flutter performance overlay, you can see much less CPU consumption when you use repaint boundary the right way, just as Craig explained it.
Another good advice is to stay up to date, simply.
Of course, some things come almost for free. Staying up to date with your libraries, SDK, frameworks, etc. can leverage many features almost for free. For example, in Flutter 3.10, you have Impeller coming to iOS by default. We ran some tests on our app. This is our home screen with Kia on top and with Impeller in the bottom. So you have much better FPS, but also much better CPU consumption just by updating Flutter.
And if you wonder what you're seeing now, these results come from the presentation from Emmanuel, one of our colleagues is somewhere in the room. It's a presentation he made that he proposed at Flutter Paris in January, so there's a replay available if you don't want to know more. And now it's this moment a bit awkward, where I have to talk about the backend. at a Flutter conference. That's just to mention, it's possible to move some logic from the presentation, from the front end to the back end, and it can be quite interesting for you, Flutter developers. So for instance, most or part of the logic presentation, mapping things, formatting strings, applying the user local to a string, these types of things, we can do that on the back end. And there's this pattern we use, the back for front pattern. So the back for front server is also your best friend forever, clearly, when you're a Flutter developer, because this way you have some logic you can just move away to the backend. If you have multiple channel and maybe multiple technologies on the front end, it gives you more consistency. You write less code. It's easy to redeploy on the backend, and sometimes you get better time to market. On the front end, what's really interesting is you get a smaller application, it's faster, and potentially you get less crashes because of all the logic you moved away. With GreenSpector, we've mentioned already, we could measure the result of this approach, this architecture, between our previous app in yellow, in orange, and SNCF Connect, which has a back for front server. And clearly, we have a smaller payload and less data on the network between the Flutter application and the server and the backend. We wanted to share with you a use case for that, as an example. It's the business tracking. I don't know how many of you have to implement business tracking in their application, but even the business tracking and the consent management, you have to remind the GDPR règlement. Even that can be done from server to server, and you could move that outside of the Flutter application. It means most of the events, for instance, if you want to track transactions, booking, and stuff, you can do that on the server directly, no impact, nothing to do on the front end. And when you have to collect something, to do something on the front end for tracking, you just have to instrument your front end. For instance, if you don't want to integrate too many third-party SDKs, you can, that's what we do, you can implement a root observer, for instance, know where we are, get the consents, get what you have to collect on the front end, and send it to the BFF. But the mapping, the data layer, all of that is most of the magic of tracking management and consent management is done on the server. And this way, you can remove from your front-end applications many third-party SDKs, which means less CPU usage, less storage.
And less much headache for the developers.
Yes, because sometimes we have versions conflicts, integrating third-party libraries, and also less calls to third-party domains. So it's really interesting for the front-end developer, we think.
Another way to limit your app footprint is to reduce the size of the downloaded bundle for your users. So here we will see quickly two techniques about app bundles and tree shaking. So Flutter is fully compatible with Android app bundles. We gain an average of 48% of the weight of the total application, and you can expect a significant gain also, and it will allow you to remove all the unnecessary code for a specific architecture in your final bundle. And know also that Flutter is compatible with Deferred Components. I will talk about it later. About iOS. Lately, Apple in Xcode 14 removed the bytecode option. We don't really know why, but we noticed that some famous applications have gained a lot in their size. So there is some workaround possible to remove and to gain a similar result that before with the bytecode option. But we're guessing that maybe Apple is anticipating that its park of devices will be more homogeneous, and maybe they will do automatic removed in the future. About tree shaking, So tree shaking is more about removing unused code for the other Flutter platform of your app, so it can remove function, field, etc. And so tree shaking is made at the compile all step when you're building your application. And you can learn more in Alexander talk at Flutter Heroes. He's describing this very well. I will just give you some quick tips on how to observe tree shaking really quickly in your app or to optimize it. So the main good practice is to use const, because const is the only thing that the compiler knows in the compile time at this step. So if you're using platform.isAndroid, your code won't be tree checked. If you want to check if your code is tree checked, you can use the analyze option in the command line when you build your final bundle. And so with the analyze size, you will get a report. And you can see if code is removed. So I will show you a really quick demo of tree shaking with the Flutter Google Wallet, a plugin we open sourced to put the ticket trains in the Flutter Google Wallet, in the Google Wallet. So basically, you can run the dev tools. You can make it from your preferred IDE. I just run it from the command line. So there is a diff section in the tool where you can import two analyses. So there is one I've already made without the const, with the basic platform.is, and one with the const in the tree shaking. And so if I make an analyze, I will just see the decrease. So it's an analysis of the iOS part of an iOS build. We can see that Flutter Google Wallet is removed, and also some Flutter localizations, some other codes. That's because we are including some accessibility code in the Flutter Google Wallet plugin.
So these were techniques quite simple to put into practice. And now let's see if we could create our own eco-friendly features.
Yes, Adrien shaped things at static time. We can also disable things at runtime. So you can implement your own custom eco mode. Generally, it comes to negotiating with your team, with your user experience, with your developer, with your PO. One compromise I think is really good is to target when you need to have an eco mode. So when do you need it? You need it when your user is in saving energy mode, when he has low battery, or when he is on an old device or low-end device. All those things you can have with classic libraries like Battery Plus or Device Plus. You can detect low-end device or old device by Android SDK version, or by memory, or by number of cores. There are many solutions.
We've seen this morning that Flutter is really good. It's a good choice for low-end devices.
Yes.
But if we want to go further, what can we disable?
Yes. So once you target when you need an eco mode, it's much more easy to cut down some code for those specific situations. So you can target the UI thread or the platform thread, like have more cache in your app in this case, or longer time to live for it. You can disable secondary SDK that are not mandatory. You can avoid or reduce geolocalization precision or other stuff precision if you don't really need them for your user. But you can also target the raster thread or the transition animation on the blend effect, opacities, clip, and shadow. These things are really hard on low-end device, so you can improve performance by just making it more simple. we tried it on our onboarding flow. So a series of 4 or 5 screens with nice animation, transition, welcoming the users. We tried it on a low-end device. We cut everything I talked about before, geolocalization, animation, etc. The result is that the FPS on a low-end device is really nice, still at 60 FPS, and the CPU usage comes down from 79% to 36% average usage. So by cutting down something, you really improve performance on your flows. The really nice thing about it is that you don't have to be a hardcore Ninja Flutter developer. Everyone can use it. There is no hardcore skill required. It's all about choices and balance.
Let's now get back to deferred components we've mentioned before.
Yes, indeed, it's another way to remove some of your features from your app, but it's a hardcore Ninja way. So here the idea is to sideload asynchronously and on-demand the features that might be not used so frequently by your users. There is no disturbance, it loads seamlessly. If you have a network available and you save network bandwidth, you can save network phone storage. It's quite easy to implement.
Let's take an example.
So we'll talk of the public transportation for Paris feature in our app. Used for metro tickets. Go on.
It's only useful in Paris, so for the other users, why not disabling it, deferring it?
Deferring it. So first step is to declare your dependency as a deferred dependency, and then you've got to call the load library function. So it's a classic Flutter feature, so you just have to handle loading, any loading of your choice for the user. And then when you will run the Flutter build app bundle, you will see some new step, a step which is called gen snapshot validation. It's one of the latest steps in the Flutter build. So this function will give you some tips on what is missing for use, what some plumbing you need to do more to achieve. So you have got to modify your pubspec.yaml, add some files for your feature, some modification in the manifest, some Gradle dark magic.
And
then every time you rerun, the gen snapshot validation step will tell you every time what's missing, will give you some file examples of what is missing, how you can implement it. And finally, in your final bundle, you will see a new folder with a .so file with the code of your feature.
If you unzip it, you see the part.so file.
And also, if you run your application and you click on your feature, you will see that the split compat will log some things when it's downloading, verifying the download of your feature, etc., installing, launching it.
So far we've seen many techniques to optimize the application, make it faster, smaller. And before we go to the testing and monitoring part, just a word about how we build, how we deploy our factories to build products and to build code. I think that's what is called the third scope when for the people studying the greenhouse gas emissions. It's the pollution when we create the product, not the product itself, but how we make it. So I'll be quick on this, but it's also a good idea to think about how we work. So as developers, our workstations, how many monitors you use. Do you turn things off sometimes, or it's always on? And how many environments you have, how much infrastructure you deploy. Especially if you work with many other developers in many teams, you might have many environments running, and all of this has an impact too for the environment, somehow. Same thing if you have long-lived feature branches, if you're used to develop features and keep them during days, weeks, months, before testing them or shipping them to production, especially if you have running environments just waiting. It's probably a bad habit, and you should have a look at what's called the 7 wastes of lean. You can do something. You can try to deliver small increments and do more continuous delivery and continuous deployment. Also, I just said we should try to have less running environments, but maybe there's an exception with the question of backwards compatibility, because that's right, to remain compatible and support all devices, it probably means requires more tests, maybe dedicated environments to test the old devices. But if we don't do that, we'll have part of our users which will be forced to change their device, buy a new smartphone, and as we've seen, it's very much polluting. So we should have also this in our mind. And now we'll quickly review solutions and tools we use and we know to test and monitor the performance over time. So we have to mention GreenSpector. We've been partnering with this French company for years. Basically, they provide audits on the performance and the carbon footprint. So last year, we reached the silver level, which is not quite a good result for an application of this size. Typically, the insights you'll get with GreenSpector is the elapsed times, the energy, the payload, and the ranking of your scenarios and flows, especially the worst, so you're able to focus on them and work on them. Currently, we are assessing other tools such as Flutter, which is that's another French company. They propose to measure the carbon footprint on the front end, but also on the back end and the cloud infrastructure. Since you're mobile developers, you should have a look at the EcoCode community project. And there's an Android and an iOS plugins for SonarCube, which are available since several months. And we can also leverage traditional monitoring tools.
Yes, we've tested some different monitoring tools, and the most famous one is Firebase, which is free, and you can get some data about HTTP latencies, about application start time. And one tool that proposes a metric that is very interesting is Sentry, with a user misery tool that gives you suspects about what part of your application is taking the most energy or the most time to display to your users. It can be from the network, it can be from assets, and it gives you the suspect.
Jocelyn, you wanted to tell us about Maestro.
Yes, if you want to write your own scenarios, one easy way to do it is to use the tool called Maestro by mobile.dev. This tool is really nice for writing and running flows. So all you have to do is write a YAML file and describe the action you want to take, like clicking a button, scrolling, or things like that. And then Maestro will run your YAML file and run your scenario. How does it help you? It helps you when you integrate it with Flashlight. So,
because you told me sometimes it's a bit flaky, and that's where Flashlight
Maestro can be a little bit flaky on certain scenario, like web views or platform view or things like that. But Flashlight is a tool wrapping your flow. It's created by BAM, sponsor here. And a really nice thing is that it can run your test command here, maestro myonboarding.yaml. You can tell him to do the flow as many times as you want. Like you want 10 times because sometimes the results are not the same. So it averages everything so that the result is more accurate. You can include the retry because of the flakiness sometimes. And you can also record the video of what Maestro is doing. Really integrate nicely with your CI, but it's only for Android. What you can have with Flashlight, so here, with my echo mode from before, I generated a report. Normal result is the application we all use. Echo result is the application targeting all devices. I can compare those with flashlight. I get a report on the left, the normal mode, on the right, the echo mode. The thing to check is the average CPU usage here, 86% dropping down to 38%. The high CPU usage dropping down to. What can it tell me more? You can see CPU usage during your flow, and you can see CPU usage with your thread. So here, I didn't gain much on the UI thread, but when I check the raster thread, by targeting all the fancy stuff, animation, I dropped the consumption of the raster thread drastically. And that's it for Maestro and Flashlight.
Thank you for the flashlight report. I think that's your turn. Let's get back to the slides. And since we were on tests.
Yes, a word about integration test and more Ninja analyze again. So you can run integration tests with a custom performance driver. And so here's some example of the code of a performance driver with a timeline, etc. The main point is that you can trace the action of your Flutter integration test, and then you will get a JSON summary and a JSON timeline. This timeline you can open in Chrome Tracing or in the new Perfetto tool from Google, which is now the default display in the Flutter debugger tools. So you can analyze your raster threads really in the deep. And with the summary, you have some nice information. For example, the average frame builds and a lot of interesting indicators.
I think we're a bit short on time, so we won't spend time on the goldens we use to test also accessibility and verify our application renders nicely on all devices with very small screens. But that might be an interesting idea if you don't do that. And also there are assessment models and questions to try to evaluate your footprint just by answering questions, but we'll skip that. As we've seen, there are many tools, solutions, tips to try to measure the carbon footprint and monitor the performance. As we said at the beginning, we've learned so many techniques we didn't know 6 months ago. I'm sure some of them we don't know yet, so please share yours. The idea, what we would like you to remember at the end of the day, that there are many ways to reduce your app footprint, especially on the user device, especially on older devices.
And there are solutions we all know, and other few of us know, like maybe Deferred Components. So learn them and use them.
Don't forget to test and monitor your app. There are a lot of tools available, and which one can fit your need for sure.
And it's not always easy to reach an impact and have results at once. So you have to be convinced, you have to try, and don't hesitate to share your findings, share what works for you. It's another way to optimize the effort and the results of everything we do. Last year, we had the opportunity to share on many topics about Flutter. So don't hesitate. If you have questions, if you have things to share, please contact us. Maybe some of you might be interested in working with us. We have jobs open, of course, so don't hesitate to have a look at our website. Don't hesitate to question us, to contact us. You'll easily find us on LinkedIn. And thank you very much for your attention.
Thank you.
Thank you.
Thank you very much for all those advice and techniques. So are there some questions on the thread? All right. Yeah. First, I have one question myself. Do you have any insight of whether a Flutter app consumes more than a native app?
We have some results comparing with our app before, which was native, but there are too much parameters to really compare. But for now, the Flutter app is consuming less than the native app. So I would say it's not a problem.
And I would add, using Flutter allowed us to write much less code and factorize and work more than as one team on one monorepo. So clearly, we improved the time to market and we write less code. So there should be a lower footprint on building things.
Okay, thanks. I have another question from Mathieu. Will you open source a Flutter package to know if a device is low end?
That's one of our ideas. That's a plan we have.
We think that would be great to have such a module.
Awesome, yeah. Definitely can help everybody implement those techniques you mentioned. How can you automatize any of those checks that you talk about, performance, footprint, in your CI and all your 40 Flutter developer experience?
I start? Okay, so we are already checking in our CI, for example, the size of the bundle. That's something quite easy you can do. Just be sure to check the bundle size and also the final APK size, because the size of the bundle does not represent the size of the final APK from the store. And also, if you run already integration tests on your CI, you can easily add the trace option, a custom runner, and so you can have some results you can compare from one launch to another.
And there are more and more tools available and coming. I mentioned the EcoCode SonarQube plugin, which is free, and it's quite recent, and maybe we could help make it even stronger.
Awesome.
Something we didn't mention as a tool is that Sauce Labs, for example, if you use Sauce Labs to get virtual devices, there is now a lot of metrics about CPU usage, memory usage. So if you run your test on Sauce Labs, you will get metrics too. Good to know.
Thanks. So with all those techniques that you presented, if I'm new to having a Flutter application, where do I start?
I guess if you start from zero, the Maestro plus Flashlight thing is really easy to get up and running and go to a CI. I would start here, and then as your team grows or as you want to put more energy in it, then go deeper than that.
And maybe you can have a look of some analysis of your bundle and test some tree shaking on your code at some cost, and try to think what features should not be in your final bundle for the final architecture. And it's quite easy to implement. So great start.
And even if you're not on your laptop and you have nothing to code and just your mobile to browse on the internet, you can have a look at for instance, the référentiel d'éco-conception provided by the French government. And I think it's being adapted currently for the whole Europe. So it's just answering questions about your digital service. So even when you can't code, you can just have a look at these questions and wonder, what could I improve?
Okay, thank you. Maybe one last question. Did you have any moments in which you had to make really hard trade-offs? Because I'm guessing all those implementation, when you target low-end devices or specific behaviors, it might make the code harder to maintain, cause bugs eventually. Did you happen to encounter this kind of or had problem months later, or?
Well, not really. There was a phase when we started to work with App Bundle, maybe. We had on some devices problems of architectures when they were downloaded from the stores. And so we had to adjust some Gradle files to get the good results for some custom device architectures. Yes, and not everything we talk about is yet in production.
Okay. So
we are really glad we prepared this talk because we learned so much. And as I said, some of the techniques we have put them in production. We did not know about them 6 months ago. Not everything is in production, but it's a good way to innovate, I guess. Preparing talks.
Awesome. Thank you very much, guys. And yeah, let's.
Thank you.
Wrap it up.
Thank you.